In this video, we're talking about how to find the degree measure of an arc given central angles of a circle. And when we're talking about arcs, we're talking about the length along the circumference or the perimeter of a circle. So for example, the arc CD, we would call this figure here that starts at the point C and ends at the point D and goes along the outside of the circle like this. So this would be the arc CD. And we denote that by the letters here. So if we were talking about the arc CD, we would have CD, and then we draw this arc over the top of it to indicate the arc CD. And when we want to find the degree measure of an arc, what we're looking at is the interior angle of the circle. The degree measure of an arc is always going to be the same as the degree measure of the corresponding interior angle. So for example, I have this interior angle here, angle CVD, indicated at 78 degrees. So that interior angle measure is 78 degrees. That means that what we call the intercepted arc that relates to angle CVD is also going to have a degree measure of 78 degrees. And when we say intercepted arc of the angle CVD, we're talking about specifically the arc that has its endpoints on the edges of the angle, where all of the points on the arc are on the interior of the angle. So the intercepted arc of angle CVD is just arc CD. So let's do a couple of examples here with this figure. We're looking for the degree measure of arc BC. Well, if we look here for point B and point C, we want the degree measure of arc BC. Well, we can see that arc BC, the intercepted arc BC, corresponds to the angle BVD, and we know that the degree measure of angle BVD is 130 degrees, which means that the degree measure of arc BC is also going to be 130 degrees. So it's as simple as that. What about this, arc BAC? Well, if we find here BAC, we have B, A, and C. It's important for us to realize that when we have an arc with just two letters, like arc BC, it's going to be a minor arc, or an arc that is less than 180 degrees. When we write an arc with three letters like this, arc BAC, we know it's going to be a major arc, or an arc that has a degree measure greater than 180 degrees. And that just tells you which way to go around the circle. So for example here, arc BC, the reason we didn't start at B and go all the way around this way to C is because that degree measure would have been greater than 180 degrees, and that would have been a major arc, but the fact that this says just arc BC with two letters indicates that it's a minor arc, so we know we're going the other way. On the other hand, arc BAC is going to be a major arc greater than 180 degrees, which means we're going to be going this way, starting at B toward A, and then around here to C. And when we're finding the degree measure of a major arc, instead of adding 36 degrees, 90 degrees, 26 degrees, and 78 degrees, what we can do is just take the degree measure that's outside of that arc, in this case 130 degrees, and subtract that from 360 degrees. Because remember, all the way around the circle is 360 degrees, so when we want a major arc, we just take 360 degrees and then subtract the excluded arc, in this case arc BC, or 130 degrees. So we subtract 130 degrees, and then the result is 230 degrees. And if we added up 36, 90, 26, and 78, we would get the same thing, 230 degrees. It's just simpler to do it this way. What about arc EB? Well, again, because it's two letters, it's going to be a minor arc, so we start here at E, we come down to B. Well, that's going to be 90 degrees plus 36 degrees, so 90 plus 36, which is going to give me 126 degrees as the measure of arc EB. So notice too that when we have multiple interior angle measures, we can just add them together to get the arc that starts at the edge of angle EVA and ends at the other edge of angle AVB. What about arc CE? So I have C and then E here. I know that's going to include angle CVD, and it's going to include angle DVE, so I'm just going to add 78 degrees to 26 degrees, and I'm going to get 104 degrees. Arc DA, another minor arc. I start here at D, and I'm going to come around to A this way. I know I'm coming this way because with two letters I know it's a minor arc, and if I went the other way, that would be greater than 180 degrees. So from D to A is going to be 26 degrees plus 90 degrees, which is going to give me 116 degrees. Arc CA, this one almost looks like it's a straight line between C and A, so we have to be really careful about remembering that this is also a minor arc because we only have 2 letters. If we start here at C and we go around D, E, and then get to A, if we add 78 to 26 to 90, we're going to get something greater than 180 degrees. So we want to make sure we start at C and come this way around to A and add 130 degrees to 36 degrees to get a total degree measure for the arc of 166 degrees. The last 2 are major arcs. We can see major arc here, ACD. So I'm starting at A. I want to come up to C and then over to D. If I started at A here and I went around to C and then around this way to D, that would be more than 360 degrees, which we never want. We want to be between 0 and 360 degrees. So I know that I have to go here clockwise, starting at A, around to C, and then over to D. So that's going to be 36 plus 130 plus 78, or because the 90 degree and 26 degree angles are the only ones that are excluded, and this is a major arc, I could do 360 degrees minus 90 degrees minus 26 degrees, and I'll get 244 degrees for the degree measure of arc ACD. And then finally arc DBE, so I'm starting here at D. If I come this way around to B and then all the way back around to E, I pass D again, which means I would have a degree measure greater than 360 degrees. That means I have to be going the other way. So I'm going to start here at D, I'm going to go counterclockwise around to B and then over to E. So the only angle that's not included in that arc is this 26 degrees from angle DVE. So I can just say 360 degrees minus 26 degrees and get a degree measure for the arc of 334 degrees. And that's how you find the degree measures of major and minor arcs using the interior angle measures in a circle.